This is a topic that's near and dear to me, and you'll understand why when I talk a little bit about my background. So we'll spend a couple minutes on that, and then we'll jump into looking at visualizing relationships. And really, this is focused on what I consider to be manufacturing kind of data and the peculiarities that you run into with manufacturing data. Specifically, a lot of times in manufacturing, you're looking at complex relationships, some data that's relating to a lot of different things. And sometimes that's difficult to visualize. And so we'll look at some techniques that JMP has for doing that. We'll also get into the questions about process capability and stability, some nice tools that JMP has for evaluating those. We'll go into sources of process variation, how to find that and investigate them. And then we'll move into how I can improve my process. And finally, there's going to be an exercise on using data mining techniques to find root cause for process excursions. And hopefully people find that interesting. I think this is a topic that hasn't been really shared very much, if at all. And so this is a piece, even if you've been using JMP for a while, it may be a relatively new kind of thing for you. So with that, I'll talk a little bit about my background. I have 35 years experience as a manufacturing engineer. My primary responsibilities were in product and process optimizations. I specialized in yield enhancement and cost reduction, and really JMP was indispensable for helping me be successful in those areas. Regularly, I had to provide support for quality issues. Some of that was generated by customer feedback, things that they would discover after we ship product to them. And after all that years of experience, and I became quite dependent on JMP during those years, I ended up switching jobs. I joined JMP about 6 years ago. And in the process of working for JMP, I had the opportunity now to run into a lot of different people, a lot of different industries. And what I find is that manufacturing engineers have very similar experiences, and these different industries can be quite different from one another. My background's more of electronics. I meet people in pharma or biotech or chemical, and if you're a manufacturing engineer, it's amazing how similar many of the experiences are. And so that's kind of the motivation for putting this together, is to try to find those common areas that really apply to all of us that are working manufacturing. And for this presentation, I'll use the word process. That's meant in a very general way. It's the steps, the equipment, the control settings that are used to manufacture your process. It isn't necessarily like a chemical process or a bio process. It could really be anything. It could be painting components on a manufacturing line. It could be, just think of it as in a very general term. And this presentation is a collection of the JMP capabilities that I found were most indispensable. It's certainly not an exhaustive list. There's lots of other things that can be done using JMP, but these are kind of like my go-to cream of the crop, bread and butter kind of capabilities. All right, so that's my background. You can see it's very much an overlay of the presentation materials and my background. First, let's talk about visualizing relationships. And again, what I find with manufacturing data is that it's not usually a simple thing where you're just taking a graph and using a simple graph to understand what's going on. And JMP has some really powerful tools for looking at complex relationships. And I'm going to show an example here using Graph Builder, which is in the graph menu, the first menu item. And what I'm going to do is I'm going to build a trellis plot in Graph Builder. And I'm going to do that by selecting process monitors that I have information on. So just grab one of those and drag that onto my y-axis. And I'm going to take my process variable and drag that onto my x-axis. And if you're new to JMP, you can see that Graph Builder is very much a drag and drop platform where you can build your graphs by dragging variables into this graph palette area. So here you can see I've got my process monitor being plotted against my different processes that are running. I'm also interested in seeing how this relationship spans across equipment. So I'm going to take my equipment, I'm going to drag it onto the group X drop zone here. And now you can see how that relationship exists across all the equipment that's being used. I have some old legacy equipment. I got my second generation tools here. And then I've got some high volume tools that were more modern, and I can see that relationship across all those. I'm also interested in looking at more than one thing at a time. So I want to look at also some other process monitors. I'm going to take process monitor 1 now. And if you notice, there's a blue drop zone that highlights that's at the end of the axis scale. And if I drag and drop into that zone, then I can simultaneously show the two monitors together on top of each other. And I can do yet another one. Let me grab process monitor 6, and I'm going to stack that on top of on all the other two. So now I can see all three of them simultaneously in one graph. And to add one more level of detail here, I'm going to use JMP's local data filter. That's on the red triangle menu, local data filter. And I'm going to look at this by shift, by production shift, just to see if there's any differences across the various shifts that are running. And I can select the shifts. And when I do that, the data subsets down to those results that were produced on the various production shifts. And I can see by clicking through here, are there any differences apparent by shift? And my conclusion looking at the data here is that the shift is not a factor, right? We're getting the same results no matter what shift is being run. But there is interesting data here on this chart. If you notice, process monitor 1 shows a clear trend. And if we go from the pre-production process, you can see this parameter is running on the high side. That was centered up when we ran to this standardized process. And then we have a new improved process. And for some reason, this parameter has shifted downward. And that's evident here. And if you look at process monitor 5, you can see that there's a clear pattern also of improved variability. We started off with a lot of variation in this parameter. We're able to tighten that up when we released the standard process. And now that we've gone to the improved process, we can see yet again another improvement in the variability on this. It's consistent across all the different pieces of equipment. It's also, as we saw previously, there's no difference by shift either. So this is something that's real. And this is a good reason why, typically lower variability is a good thing in manufacturing. You always want consistent results. And this would be a good reason to try to implement this improved process. However, as we see in this other chart, we've had a shift in the performance of this other parameter. And perhaps this is going to become a capability issue. So maybe what we'll have to do is center this process up a bit before we can implement the improved process into volume production. And if you look at the amount of data that's being shown on this graph, there's a lot of information here. This is why I say JMP has some great capabilities working with manufacturing data. Even though there's a lot of dimensions here, the graph is still very, very clear. It's very easy to interpret the results. And this is something that's really special with JMP. You're able to get this amount of information out of a single view like this. Also, it's interesting, people like to look at yield trends. I'll show you an example of that. So again, I'm going to go to the Graph Builder platform, and I'm going to take my date parameter, drag that onto the x-axis, and then I'm going to take my yield, my test yields, and I'm going to drag this onto the y-axis. And now I'm plotting test yield by date. There's collections of data that's in here that we'll have to separate out. That's going to be easy to do using the local data filter. But before they do that, I'm going to also look at test yield by the equipment that's being used to test the product. I'm going to drag test yield. I could drag it up here to the group X and get this kind of a view of it. But if you notice, there's also another drop zone here for wrapping. It's over here in the corner. And when I drag it on the wrap zone, then I get more of a 2x2 view of my data. And I kind of find this a little easier to read. So I have my test equipment that's in the lab. I got an internal factory. I got the domestic subcontractor that's doing testing for us, and I have an offshore, perhaps a low-cost operation, and I can compare the results across them. I still have a mixture of data in here. I need to separate that out, so I'm going to use my local data filter here to do that. I'm going to filter on the product. There's mixtures of product in here. So if I take my product and filter on it, now I can see in my high volume part, yield trend, my legacy part, and then NPI is a shortcut name that I use for new product introduction. So this is a part that's just recently being released into a production mode. You can see from the trend here that in the high volume part, we've had pretty good success. We had some yield enhancement activity that went on, and we were able to get our yields up to a nice level. So good success there. We have a legacy part. It's bouncing around a little bit, but it's not really trending in any particular direction. This would be a case where we want to sustain it, but we just don't want to see it take any major excursions down, for example. So we keep an eye on it. And then our new product that we're just introducing, you can see we had fairly good yields when we initially released it, high hopes there. But as we've gone into production mode, the yields have gone down. This is pretty typical from my experience because as you go into production mode, you're introducing a lot more variability, like different equipment that's being used, moving things around a little bit. So a lot of times you have to sort of optimize conditions, as you go into high volume. And so the same level of effort that we put into the high volume part to get our yields up to what we think we can achieve is begging to be done on this new product being introduced. And again, we're looking at a lot of information here. We're looking across different equipment, we're looking over time, we're looking at subsetting the data by product, and yet the data, even with all that amount of information, the chart is still very readable. And then I'll show one more visualization here. This is using our distribution platform, which is in the Analyze menu, the top of the menu there. And I'm going to very carefully select the order here. I want the process to be the first item that I select. And you'll see that in a minute why I did that. And then I'm going to look at all my process monitors. So I'm going to grab all of them and look at them afterwards, or following. And here you can see I got my distribution report. And even though there's different data that was given to the platform, we have categorical data, which is the process, and we have numerical data, which are the monitors. The same platform distribution can handle them easily, and it treats them differently though, because categorical data is summarized by the frequency of occurrence of the different values in the column, and you get a frequency kind of histogram showing. Whereas a numerical data, you can see more of a histogram view like you'd expect. You have an outlier box plot showing here, and you also have statistical summaries done on the data, like quantiles and mean, standard deviation, and so on. And one of the really powerful features in JMP, and again, this is very, very handy for handling manufacturing data with complex relationships, is this idea of interactive graphics. And this is done simply by selecting data somewhere. You can do that graphically or otherwise. And as you select data, those rows are selected in the underlying data table. And you can see, because the rows are selected in the table, that same selection is showing up in every graphical result is generated from the data. And from that, you can see very clearly a relationship here between pre-production running on the high side, standard is well centered in distribution, and the improved process is running on the low side. This is the exact same issue we saw previously with the trellis plot. And again, this is just using interactive graphics as a way to kind of clearly see that relationship. And this selection of points can happen anywhere. You can select points in any graphical result that's available on the data, and then that same principle applies wherever you select the points. Whatever graph you use, it's going to be applied to every graph that's generated from that data table. So that's a distribution platform and interactive graphics.